If you want to have highlighters, you can. There are 5 theorems that prove triangles are congruent. What is the name of one of them? Side, side, side. What does side, side, side say? What would be congruent on side, side, side? All the sides. This is in the box if you don't have it. So 3 sides would be congruent to 3 sides. You do have it? You do. Okay. 3 sides would be congruent to 3 sides. What is another theorem? Side, angle, side. So you have 2 sides marked congruent to 2 sides. Where does the angle have to be? In between them. So in between. Has to be up here. Has to be touching both sides for it to be side, angle, side. What is another theorem? Angle, angle, side, which means you have 2 angles marked congruent to 2 angles. And then where does the side have to be? Not in between, yeah. You could say after if you want. It's going to be a cross. So it could either be here or it could even be here to be angle, angle, side. What it cannot be here because this would be in between both the angles and that would be angle, side, angle. So it will be a cross from one of the angles. Whereas angle, side, angle, the side will be in between. So I'm going to highlight the same 2 angles as before. And the side would be in between them, touching both of those angles. The last one is a special triangle. It is a right triangle. What is a theorem that only applies to a right triangle? Hypotenuse leg. Where is the hypotenuse always located? Across the right angle. So which side would have to be marked congruent in my first triangle? AB would be marked congruent to ED or DE. And then a leg just means a leg marked congruent to a leg, the corresponding leg. So BC and EF, or AC and EFD. Sorry, I said a lot of letters there. But that's hypotenuse leg. So remember the ones that are not, because if you're given a multiple choice question, then you can automatically, cancel out some. So not theorems, angle, angle, angle is, that's not an A. Angle, angle, angle is not a theorem. Side, side, angle is not a theorem. Those are the only 2 I see the most. They don't exist. Because one spelled backwards is a donkey, and then the other one is not a thing. So, all right, and then what are congruent things not marked that can be assumed? So in this first picture, what would not be marked congruent but that we could mark congruent? Vertical angles. Vertical angles are congruent. And then in the second picture, a shared side or a wall. You're correct, that reflexive property. This last one, this is supposed to be a parallel. This one pertains to honors only. I'm recording if you didn't know. But alternate interior exists if you have parallel lines. So if you have parallel lines, I marked it in blue. It should have already been on there. So these lines would be parallel. I'll show you why they're alternate interior. They're inside the double lines and on opposite sides of BD. So that's why they're alternate interior. But only if the lines are parallel. Those are the things that we can mark. Otherwise, we can't just say, well, they look congruent, so I'm going to mark them congruent. This is it. The other part of Chapter 5 went into triangles and their measures. This first one deals with the anterior sum of the angles. What do all the inside angles add up to? 180. You can kind of see it in a pretty picture. If you take all 3 angles, they make a straight angle together. Exterior angles. In this picture, we would take A and B. They're the 2 opposite angles that are inside the triangle. They're not adjacent to the exterior. They would add up and equal the exterior angle. which in this case is E. So we'll use that below, find the value of x. I know this isn't printed, it's super great. I did the best I could. But we're going to take each angle. So 2x plus 96, because each of these are on the inside, right? So they add up to 180, plus x plus 12 equals 180. Combine like terms, 2x and x make 3x. 96 and 12 make 108. Subtract 108, 3x equals 72. Divide by 3, and x is 24. So it says find the value of x, and then we're also going to find the angles that are missing. How do we find the angles that are missing? You just plug them in. Yeah. 2 times 24 is 48. So it's one of them, and then the other one was just x plus 12, so 24 plus 12 is 36. Whereas the last one on this page, angle 1 is 40 degrees, and then angle 2 is 4x degrees, and angle 4 is 60 degrees. So then what could we do? You could do a couple things here technically, but if we want to use the theorem, we would do 40 plus 4x equals 60. Subtract 40. 4x equals 20, and x equals 5. This one just says find the value of x. When you're ready, we can turn the page. Classifying triangles by sides. I don't know why there's a blank there. There's not anything interesting to put there. But if you have 3 sides that are congruent, like the first one, what do we call that? Equilateral. The second one, if we have 2 sides congruent, isosceles, and the third has no congruent, which is scaling. So equilateral, isosceles, and scaling. Equilateral, isosceles, and scaling. Remember that the number of congruent sides they have, that's how many congruent angles they'll have. We'll talk about that here in a second. For classifying by angles, we always look at the largest angle. I'm pretty sure this first one is not acute. I think this angle is a right angle, but we're just going to pretend that maybe it's 89 degrees. But we're going to say that an option is acute. If all of the angles are acute, then it's called an acute triangle. The next one, what's the largest angle? What kind of angle is it? It's obtuse. The third, the largest angle, is right. And then the fourth, all of the angles are the same, so that's called equiangular. Equiangular. Good. If a triangle has 3 congruent angles, it is both equilateral and equiangular. Or equiangular and equilateral, doesn't matter. And equilateral. It will have all congruent sides and all congruent angles. So what will every angle equal? 60 degrees, and every side will equal each other. Or the sides. The sides equal each other. So like in this picture, all the angles would be 60 degrees, and 60 degrees. But all the sides would be the same number. So pick a number. 5. All the sides would have a length of 5. Alright, isosceles. If a triangle has two congruent angles, it has two congruent sides. The sides and angles are located across from each other. So this bottom one, we've got two congruent angles. The congruent sides will be across from the two congruent angles. So I would mark them if I were you. So the sides would be equal to each other and the angles are equal to each other. Then the same thing, you're given congruent sides, so the angles across can be marked congruent as well. So in this first example, find the value of x. We have two congruent sides. So which two angles are going to be congruent? We've got a blank, a 40, and an x. Yes, give me the letters. X and the blank will be the same, right? So then you can, the math way, you can add them, set them equal to 180. You can do this in your head also. You don't have to do the equation way, but you can. Combine like terms, you get 2x. Subtract 40. 2x equals 140, and x equals 70. Then the last one on this page, we have two congruent sides, which means we have two congruent angles. So which two angles are going to be the same? 75 and x. So x would be 75. Good. They do get harder. This next one is for sure an honors question. You would be asked like a problem like this and have to find your way to x. So always start where the most information is and then work your way to x. What is the only information, the only number we have technically? 120, and it is a linear pair with the inside angle. So what would I do to find that inside angle? Subtract. So this would be 60. Now we know this triangle is also isosceles. So two angles are going to be congruent. This angle will be congruent to this angle. All right, so what are we going to do to find it? Subtract 60 from 180 and then divide by 2. So each of those angles equals 60. So 60 and 60. How does this help me with my next triangle? It's vertical to this one. And then what kind of triangle do we have over here? Also isosceles, which means two of the angles are congruent. So across from this angle is this blank angle down here. Across from this angle is the 60. So that means this blank angle will be 60. So then what will x end up being? 60. You do have a problem like this on the honors exam where you have to find your way to the x. Your bonus also is similar to that. The next one is on both exams. Which two letters will be congruent, A, B, or C? Which two angles will be congruent? A and C. So can I call C x? No. I have to call it the same thing I called A, and A is called 6x plus 6, so C is called 6x plus 6. We're just going to set this one up just to save a little bit of time. So we would take 2x plus 6x plus 6 plus 6x plus 6, and it equals 180. You'd combine like terms and all the things. I have faith in your algebra. This last one, we're given two side lengths. Are they the side lengths that are marked congruent? They're not. Can a side be equal to an angle? No. No, never. Sides are equal to sides, angles are equal to angles. So we need to figure out what kind of triangle is on the inside, because this is kind of like a trick question. If this angle is 60, what will z and y be? 60. And here's why. Z and y are congruent, right? 180 minus 60 is 120. And I know I would have to split 120 evenly between z and y. So each of them are 60 and 60. So it's not only an isosceles triangle. What other kind of triangle is it? Equiangular, which means it is equilateral. So technically all the sides are equal. So we could set these equal. And then you would solve. These are the last two. This one is definitely an honors question. This next one is not. So I already know some of my standard students aren't here today, and if they're watching this video. So I'm going to do this one first, so they could just stop the video if they want, and then do this one second. Does that make sense? So we'll do this one first. Find the values of x and y. So do you want to find x or y first? X sounds good. Is x a side or an angle? Angle. So we need to find other angles. So what is the only information we're given about the angles? We got an equal angular triangle here, right? So what is the measure of each of those angles? 60, 60, and 60. So then we got to figure out how to take that information and move into the next triangle. So how can I do that? Correct. They make a linear pair up here. So then what does this top angle have to be? 120. Good. Then what kind of triangle is this one? Isosceles. So two sides are congruent, two angles are going to be congruent. So what's the measure of the blank angle going to be? It'll also be x. Alright, so these are the same measure. Then you can add them up, set them equal to 180. So I'm going to write down here 120 plus x equals 180. We math. 120 plus 2x equals 180. Subtract 120. There's also a way to do it in your head. 180 minus 120 is 60 divided by 2, and each of those angles has to be 30. Whereas the sides, 5y is a side, right? On what kind of triangle? Equilateral. So I'm going to erase all the angles because it'll get confusing for you to look at. But we're just going to look at the sides. All the sides are going to be the same. So they're all 5y. Ooh. And what kind of triangle is this one? Isosceles. And they're already marked congruent, these two sides. So that means I could say that 5y equals 20. And that y is 4. Alright, then we have one more. It is an honors question. Find the value of x and y. Do you want to do x first or y first? Y, sounds good. Is y a side or an angle? It's a side. What is the full length of this side? Okay, better question. What kind of triangle is the whole triangle? Equilateral, equiangular, right? So each of those angles is 60 degrees, but each side length will be the same. So what's the length of each side? 46. So the whole side length is 46, so then y is 30. X is an angle, so we're going to write in all the angles. This one was 60. This was 60. This whole angle is 60 degrees. Just make sure you know that x is not 60, just all the angle. So then, where would we like to go from here? There's a couple options. The linear pair sounds good. These two are a linear pair. You got 80. What's the measure of this angle then? 100. And then you just got a triangle, right? So you got 60 and 100, which makes 160 from 180 means x is 20. That's it. That's the end of chapter 5.